In this lecture, we will learn about the logistic regression, its basic operation, and implement it in Python. First, we learn some basic information about linear regression. Linear regression is a supervised machine learning algorithm where the predicted output is continuous and used to predict values within continuous range such as sale and price. Linear regression has two main types: simple regression and multivariable regression. What is simple regression? Simple regression defines a follow equation: y equal to mx plus b, where m and b are the variables, and our algorithm will try to learn to produce the most accurate prediction. X represents our input data and y represents our prediction. For multivariable regression, we have more than one variable. For instance, the variable x, y, and z represent the attributes we have about each observation, and w represent the coefficients or weights. Our model will try to learn. Then we have this equation: f x y z equal to w1x plus w2y plus w3z. For example, suppose we have a database from some companies that spend for radio advertising each year, and its annual sales in terms of units sold. We are trying to develop an equation that will let us to predict units sold based on how much a company spends on radio advertising. The figure is shown, this data. Our algorithm will try to learn the correct values of parameters in model. By the end of our training, our equation will approximate the line of best fit, as you can see here: radio, sale, and our learn regression line try to be close to the line. Logistic regression. The logistic regression model is a widely used statistical model which is primarily used for classification purposes. It is a supervised learning classification algorithm which is used to predict observation to a discrete set of classes. It is one of the most simple, straightforward, and versatile classification algorithms which is used to solve classification problems. Also, the output of logistic regression problem can be only between the 0 and 1. Logistic regression is an extension of linear regression, where the dependent variable is categorical and not continuous. Unlike linear regression, which outputs continuous number value. Logistic regression transforms its output using the logistic sigmoid function to return a probability value which can then be mapped to two or more discrete classes. Logistic regression is an extension of linear regression, where the dependent variable is categorical and not continuous, as I mentioned. Linear regression and logistic regression. As I mentioned to you, linear regression gives you a continuous output. An example of the continuous output is house price and stock price. Logistic regression provides a constant output. Example of discrete output is predicting whether a patient has cancer or not. Another example is to predict whether the customer will churn. As you can see in these two figures show the functionality of linear regression and logistic regression. Linear regression maps a line on input data. On the other hand, logistic regression uses a sigmoid function for mapping on data. For more understanding, let's look to functionality of logistic regression and see how does logistic regression work. As we said, multiple or multivariable linear regression equation is y equal to beta 0 plus beta 1 x1 plus 2 beta n xn. Y is dependent variable and x1 to xn are explanatory variable. This is the sigmoid function, and here is decision boundary that we have. If we have the sigmoid function p, our current prediction returns a probability score between 0 and 1. So if p greater or equal to 0.5, we can categorize as a class 1. If below 0.5, the class can be 0. This is the decision boundary that we have in this sigmoid function. Now let's have a look to binary logistic regression in Python. And also I want to discuss about type of logistic regression. There are different types of logistic regression. The first one is binary logistic regression. The target variable has two possible categories. For example, categories are yes or no, good or bad, true or false, spam or not spam, and pass or fail. Another type of logistic regression is multinomial logistic regression. The target values has three or more categories, which are not in any particular order. For example, categories of fruits: apple, mango, orange, and banana. And another type of logistic regression is ordinal logistic regression. In this case, the target values has 3 or more ordinal categories. For example, the student performance can be categorized as poor, average, good, and excellent. So, in order to discuss about logistic regression and how to implement different type of logistic regression in Python, let's start with binary logistic regression in Python. Binary logistic regression in Python. In this session, we want to classify diabetes dataset or diabetics using logistic regression. To this aim, we use a scikit-learn or scikit-learn package in Python. Scikit-learn is the most useful and robust library for machine learning in Python. It provides a selection of efficient tools for machine learning and statistical modeling, including classification, regression, clustering, and dimensionality reduction via the consistent interface in Python. First, we import necessary modules. Our example is predict diabetics using LRC, or we call Logistic Regression Classifier. The first step, you have to import necessary modules. We use pandas for working with data frame in this project. For visualization, we use Seaborn, that is a Python data visualization library based on a matplotlib. For building a model, we import logistic regression from scikit-learn, from scikit-learn.linear model. Import logistic regression. And for creating test and training data, we use train test split function from scikit-learn module. Finally, the accuracy score function was imported to evaluate the performance of module. So, we downloaded data set and save it to data folder. We already put diabetics CSV and we put in data folder. We read it by using pd.readCSV and store it in data variable. This is our variable. First, you need to read it from the source of this data set, and later you have to do some pre-processing. For missing value, we use drop_NA method for data variable. Then we print the dimension of data that you can see. After you put the print, this is the dimension of your data. 768 row and 9 column. And also you can list the column of data, means that the feature. After you list and print the data.column, all feature from this data set are available. The feature in this case are pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, and the other column that we have. The columns, the outcome columns, which you can see here, shows the label or class for each sample. For example, we have sample for class 0 and 268 for class 1. The result is shown in this picture and I will show you now. So when you want to get the info about the data, you can simply write data.info. When you put data.info, when you run it, they give you 9 columns of data. See here? And when you target the outcome, and if you want to know about outcome in column 8, just simply write data bracket outcome.value count. Then after you run, they will give you 500 categorized class 0 and 268 categorized as class 1. And when you want to plot the outcome, just simply use sns.countplot. Here you can see the result is shown here. For example, class 0, the total number are 500. Class 1, the total number is 268. Very simple. By X and Y, you can plot it. Now let's go to discuss about selecting the feature and why we have to select the feature. This is very important part. Here we want to split data set in features and target value because your raw data is still not splitted. They have the column, they have the feature input and output. Then nobody's know what is input, what is output. So we store the outcome column in label variable. Yes, in variable label. Outcome, because you already have the data and the outcome was the feature of data. Then you can put in label or whatever you like, you can make it or rename it. And some of the other columns means that input variable. You can put all the other variable in variable name feature columns, or you can put as inputs. When you plot data and data feature column, all data coming to data variable. Yeah, it's already run. Now it's time to split data into training and testing. We separate 80% of data for training the model and remain means that 20% as a test data. So by this training data, testing data, train label, test label. Just in order to make it more simple way, try to set train X, test X, train Y, test Y. Because you already have the X as input, Y as a output. After I run this section, it is already completed. Now it's time to do the classification with LR, Logistic Regression. We use Logistic Regression in scikit-learn with default parameter for building a model. You can also change or modify the parameter. Then fit the model. You just introduce the model and fit the model with data according to given training data by using fit parentheses. Model.fit training data, training labels. Now we have to evaluate the performance. So in this case, you can put predicted and put model.predict as data. After I run, now it's time to see where is the result. The result is stored in predicted variables. Now we have to evaluate the performance of the model. So here we have test labels, and you can see how they have this system, and you see in the predicted what we have in predicted. They show like this. So test label are this one, and our predicted label are this one. For calculating metrics or performance, we use accuracy. That's the formula is the accuracy formula equal to the number of corrected prediction divided by the total number of prediction. In order to print the accuracy, you can simply put accuracy equal to an accuracy score and predicted and tested label. Means that from the tested label you predict our test label. So here you can see the accuracy is 77% in this example. Now let's have a look to multi-class logistic regression. In this example, we show binary classification for multi-class. We follow these rules. For example, procedure. Divide the problem into n+1 binary classification problem. +1 because the index starts at 0 for each class. Then predict the probability the observation are in that single class. Then prediction equal to max probability of classes. For each subproblem, we select one class, yes, and lump all the other into a second class, no. Then we take the class with the highest predicted value. The advantages of this model, multi-class logistic, does not require high computing or computation power, easy to implement, easily interpretable, and these advantages are logistic regression is not able to handle a large number of categorical feature or variable. It is vulnerable to overfitting. It cannot solve the nonlinear problem with logistic regression. I hope you enjoy, and we have some more example, and we will look at another classification method in the next lecture.